So in this video, we're going to cover how to draw force diagrams for objects that accelerate. We need to remember that in situations of acceleration, okay, if we have a positive velocity and a positive acceleration, that object is going to speed up. And if we have a negative velocity and a negative acceleration, that object is going to speed up. On the other hand, if we have a positive velocity and a negative acceleration, that object is going to slow down. And if we have a negative velocity and a positive acceleration, that object will also slow down. So the idea that we need to have here is that in order for the object to speed up, my acceleration has to be in the same direction as my velocity. In order to slow down, my acceleration has to be in the opposite direction. Same direction, opposite direction. We have to remember that. Don't forget that. Now, the next thing that we go to in this whole deal is, where does force come in? A force is a push or a pull. Now remember, why are we trying to push or pull? We're trying to push or pull to change motion. Or in other words, we're trying to do that in order to accelerate. So the next key topic that we have to consider is that the force, the net force or the resulting force, has to be the same direction as the acceleration. So that's what we're going to look at here in the next couple of slides. All right, so I have a book being pushed to the right across the desk and speeds up. This is the key. Speeds up. What direction is it speeding up? The same direction that it's being pushed. So here I always want to draw a diagram. Here's my book. It has a velocity to this direction. And it is speeding up, so that means my acceleration has to be in the same direction, so it's also going to be here. And if that's in that direction, that means that my net force is also in that direction. And I'm going to start using this for net force. Same thing. These two are the same thing. So we'll get rid of that one. My net force is also in that direction. So the first thing I need to do is identify the system. Here is my system. I'm going to draw a box. We are on Earth. I know that. So I'm going to draw an arrow down. The force of gravity on the book by the Earth. I have no motion in the up and down Y direction, so I'm going to draw an arrow up, similar in length. Force normal on the book. It's a desk. Here it says desk, so I'm going to use D. Now, that takes care of my up and down, and these two are the same. I can do that to help me see that. Now, what do I do in this X direction? In the X direction, it is already moving. It is being pushed. I know that because it's here. So I'm going to draw this push in this direction. It is a force applied, okay, by, I don't know, it doesn't say who's pushing it, by a person. We assume the person is pushing the book. Force applied, on the book by the person. And this is okay. This is what we're looking for. We have a net force in this direction, meaning we don't have one over here. However, it does not state that there is no friction. draw a force diagram for the box as it accelerates. So a little bit different here. So I'm going to draw a book, okay, being pushed across frictionless ice. There's my book. Same thing, velocity. We'll assume it's going in the same direction. It's accelerating. Okay, it doesn't say, it probably should say speeds up. So I guess it could be slowing down, but generally speaking, in this case, there is no friction because we're frictionless, so it almost has to accelerate if we're pushing it. That means my net force will also be in that direction. So I identify my target here. My target is the book. Always starting with gravity. Fg on the book by the earth. And I have an upward force normal on the book by the ice. And then I'm being pushed. Doesn't matter which direction we're being pushed as long as we tell us. I have a force applied on the book by the person. And that's it. Because we are frictionless, I do not need anything over here. And that would satisfy that situation. Let's look at one more. We've looked at two situations of speeding up. Let's look at what happens when we slow down. So remember that slowing down, okay, indicates that the velocity, so the book now is being pushed to the left. So that means my acceleration needs to be in this direction, opposite that, because I'm slowing down, slows down. And that means this is also going to be my net force. So as always, I identify my system. You can circle it or dotted line, it doesn't really matter. Draw a box. Force of gravity on the book by the earth. Force normal on the book by the desk. These two are the same. Slows down. I do not have to explain why it's already moving. I do not. I simply need a net arrow in this direction. The force of friction on the book by the desk. That's it. Oh, I'm sorry. It is being pushed. So I do need this one. It just needs to be smaller. On the book by the person. And I hope that helps. These two are not equal. So here I have a net